Hey guys, Kuzi here. Today we're going to land on the moon. We're going to design and launch a rocket that will rendezvous with my moon station. It will then deposit an unmanned science rover on the surface with a Skycrane. That'll collect some science, and also some Kerbals will jump out, run around, plant a flag, and then take off, rendezvous back with the moon station. First things first, let's check out the rover in the spaceplane hangar. So here we are in the spaceplane hangar, and I'm real quick going to show some mods we use. First and foremost, I'm going to show Craft Manager. I love this mod. It helps sort, tag things. We can bounce between if it's a sub-assembly or if it's in this, in the VAB or the SPH, depending on which one. This is the first version of the craft we're going to use today, which is actually this guy here, and we'll learn about this first one a little later. A couple things were wrong with him, but here's this rover. This is what we're going to be, our payload, our unmanned science rover. It's going to last forever on the moon. Also, I use MechJeb. We're going to use that today for its autopilot, its rover autopilot function, which is really, really good. Kerbal Engineer, which obviously with this part we're not seeing anything, there's no rocketry involved. What we do care about here is the electric charge down there, which is relatively sufficient for what we got here. It's a pretty low weight, about 1 ton. You can see a bunch of that's monopropellant, about a fifth of that is actually monoprop. I use Kerbal Alarm Clock, and then Editor's Extension Redux I love. Helps with angles. We can go all the way down to 1 degree down here. You see toggle snap, symmetry, all this and that. So just to go over the design of this rover, it's a micro rover. It's got the Clampetron docking port Junior on the front. Starting with the electrics, first we're just using the Provodyne Rovemate. That comes with 120 electric. I like to color my stuff. Let's go with this black gold look. It looks cool. Inside of it, I've also got 2 batteries buried. I like to use the offset tool. You can see here I have an experiment storage unit stashed in there, 2 monoprop tanks, which we'll go over later. Obviously, I've set these photovoltaic panels a little in, etc., etc. I use it. It's fun. This guy's actually sunk in. This is what will connect us eventually to our rocket. We got two 1x6 on top, and then we've got some backup little panels just in case. I've learned that. You should keep those. Our main energy eaters are going to be obviously driving. That's going to be the biggest one with our wheels, which, quick tip, make sure you turn steering off for the rear wheels. It'll help on the moon. We don't need to turn so fast. You're held at the maximum speed you can go on the moon because of gravity anyways. You can't really go too fast or else you end up vaulting off of it into no man's space. So on it we've got, I like to use RemoteTech, so it makes it a little bit more difficult to play with, but it's a fun little realism type of deal. So I've got both a HG5 high gain antenna. We're going to point that up, and then I've got the Communitron 16. I've also got buried in here one of the this guy's buried in there. It's just a backup plan just in case, because I don't cheat that bad, so he stays on in there for emergency purposes pretty much. Next we've got the science. That's the primary function of this. I've included basic stuff, the seismic accelerometer and the press map barometer. We've also got the drill here. That's a fun little thing. The scanning arm, stuff like that. We've got the experiment control unit buried here. I like that. There it is in there. And that just helps collect the science. We've got the lights on the front. Those will eat a little electricity, and they're very required on the moon. It's dark. The docking port is so we can save it as a sub-assembly, and also we can use that to connect to the spaceship and our launcher vehicle. As I said before, I've got these RCS tanks buried in here, and those power these. This probably won't be enough to really save our bacon, but it'll help us stabilize just in case we go a little too fast. And then I like, as I touched on these wheels earlier, I like these because they can fold up for when we're flying, so we can kind of get the whole thing in a little bit smaller space. Then let's save this as a sub-assembly so we can connect it later. So what we're going to do is reroute, make the Clampetron docking port the master part, click it, move it over to our Rover section, drop it, UMR Science. And before we do anything else, we're actually going to test this bad boy. So let's go on and do that. Here's our rover. We're going to test it real quick. Two things I'm going to show mods wise is for science here and now. Notice I have a little drill sample, and this is my little sample drill back there. I have it silenced, it suppressed the results window. That's fine. And this is ship manifest, and I like ship manifest for its deployment stuff. So we want to turn everything on. There's our lights in the front. Make sure those turn on. We want to extend all of our antennas. Notice, because I buried that transceiver, we still had connection to do all these things before I deployed the Communitron 16, which will probably be our main transmission device. We want to make sure these didn't break and they still deploy. They work okay. Here we go. We'll deploy our solar panels, make sure they don't break when we do anything. We see some part clipping. Hey, it's Kerbal. These things look a bit wonky, but in a zero grav situation, they won't produce any drags. It doesn't matter. And we'll drive it, make sure it goes. Remember, turn it. It's pretty stable. It's about as fast as we're going to be driving it on the moon. Not much more than 10 or 12 meters per second. It just gets a little dangerous out there. Our RCS turns on, works. Driving. We can use our sensitivity function over here. Kind of helps us not go so crazy. If you notice, holding the button down kind of makes it a bit more stable, so we can, even in this high gravity situation, we can whip turns left and right, spin around. Looks like everything's going to work. Lights are good. They're pointed. You see, we can see we're going to light up in front of us. You know, we can tell. Then we just want to check our power consumption. Looks like we have power positive net consumption, so that means we'll be able to drive it all day for the most part, and then drive it a little bit at night and get it to a safe spot, park it, let it recharge. We can see here these panels are blocking these other ones. We see it's blocked by the antenna, actually. This other one is blocked by the other panel, so we can just make sure that that's going to work. We'll retract these. Direct sunlight, energy flow, boom, boom, boom. And the last thing to test is to make sure when we retract these that it sits nice, that we can stabilize it. We can see 0.0 on a flat surface. That's good. We can, I believe, use the gear. Yep, the gear button, G on the keyboard to deploy, and it drives again, as we can see. Carve some donuts in the runway real quick. Hit the brake. Brakes work. Doesn't flip forward. Show that a little closer up. Turn off. Just make sure it doesn't get all wonky. You see that? Pretty nice. Let's go forward and try it. We have nice center of gravity on this vehicle. Grip. Cool. Here we are in the V8B. We're going to load up our rocket. I've already built and designed everything and tested it, but I'll go through twice. First, I'm going to go through by stage, the design and build, and then I will go through by part functionality, the design and build. And they kind of follow similar order, but not quite. So starting with our liftoff stage, I've got a mainsail here. There she is. Mainsail with a bunch of liquid fuel and oxidizer above her, and then 6 kickbacks. I do not have these with a decoupler. I've set them to 55.5% thrust, and what that will do is actually roughly equal the same burn time as the mainsail. And I did that for the reason I will explain now, which is here in Kerbal Engineer at the bottom we have our staging, right? And when the mainsail and the 6 kickbacks burn together, we see we have a 1.46 thrust to weight ratio. That's pretty good, and that's going to get us up into space. It's not going to get us to orbit. We need that second stage to orbit. But remember, we're taking off from the ground, so we're starting at altitude of 0. So we check with the atmosphere. Together at liftoff, we're going to have 1.32. Still acceptable. And as we go up in altitude, we can see it grows, and it eventually will peak. 1.46 is our max, right? We see that for both of these stages, in fact. So we can find exactly where by scrolling down, and we'll say late 1.45. So somewhere around 14 kilometers, we're going to reach our peak thrust to weight ratio. We want to dump these at the same time for our next stage, which is our orbit stage. And our orbit stage is a skipper with some more liquid fuel oxidizer above it. And that'll provide us right here with the rest of the delta V we need to get to orbit. Low carbon orbit, LKO. We'll have a little bit of fuel left over, likely. So part of this stage will be used as the transfer stage, and the rest of the transfer stage will occur from these 4 thuds. And these 4 thuds are actually right here, and they're pretty integral to the rest of the mission as well. They're going to be what completes the transfer, completes the rendezvous, and then actually is what lands and takes off back from the moon. And then above that, on our return vehicle, which is this Mark 1-3 command pod, we have a Poodle. And the Poodle has only a little bit of fuel, but it's got enough to get there. So that's them by stages. So here's our landing and Skycrane stage. We can see I still have a Clampetron at the top. I've got some comms just in, stay safe. I use RemoteTech. We've got our docking ports affixed at the bottom with our sub-assembly we installed. We've got those actually linked in here in the staging. And what this is, this will deposit and then land next to our rover. The top bit, which I will put back, will be what stays attached to the station core and what we use to transfer some Kerbals back home. So we will recoup some of that cost. We are in a career save here. Everything else will be left permanently. So there's that. We've got just enough DV to get there and back. We're going to rely on a little bit of refueling from my moon station, not a ton though. You can see in the top section we have a set of 3 air brakes, a set of 3 radial parachutes, and we got some landing legs for that too, just in case. I'm not sure how hot this thing's going to come back in later. We'll figure that out though. Cool, so we're going to launch this. I'm going to skip the actual launch and orbit and all that. That'll be for another day. So here's our moon station, and we've docked our Moon 2 craft with its lander, Skycrane, and rover all attached. that video is for a different time. So what I've gone ahead and done is I've transferred some crew using my roster function here, or my crew transfer actually up here, and I've made sure I've gotten a pilot and an engineer. I'm going to skip the scientist for this landing. Obviously on a science-based mission we should bring a scientist, but I'm going to bring an engineer just to get him some experience. We're recharging our batteries right now. We were on the dark side when we rendezvoused, so we need to get our electric charge up, and we can see that's going right now. We're about halfway. It's no big deal. We're firmly planted about halfway into the sunny side. This is probably ideal for us to land. And what we will end up doing is disconnecting the bottom portion here, flying it down, and landing it somewhere, probably in this area, around here. What this will allow us to do is keep a little bit of sunshine so we can at least test the rover for a couple minutes before the sun turns out for a while. Or the moon, I should say, turns away from the sun and revolves, rotates out, and that'll be that. So let's go ahead and take care of that now. So the last thing we are going to do is refuel our ship using other containers. We can see this is for our lander Skycrane, and I'm going to use this smaller tank as an intermediary tank to make sure they stay in equal proportion. We don't want to have too much of one and not enough of the other, or vice versa. So from here we'll use it as an intermediary. We'll fill it up with the other tank. We're looking to have around 1,500 or so dB. That's enough for us to undock, head down to the moon, deposit our rover, land near the rover, inspect the rover, and take on back up to the station after probably one rotation. So that filled up. Out. There we go. This should be enough. I'm going to actually give it one more just to stay safe. It'll make it a little bit less efficient because it'll be a tiny bit heavier, but we've got plenty of resources available to us, so we might as well do it. Well, that's filling up. There we go. Out, and should have plenty of dB now. Time to do the fateful. Press the button. There it goes. We decoupled. Can see our landing craft remains. And here's our other bad boy, our lander Skycrane. So we're going to turn our RCS on, put it in docking mode real quick so I can back out of this fairing without dinking it. There it is. Backing out. Point ourselves retrograde. We're gonna try and land right around where we are. We got 1616 dB, so that's perfect. Just enough. Here we go. Now our panels can be left open because of there's no atmosphere on the moon, but we're going to deposit this thing, so it may not be the safest to have panels open, or this antenna for that matter. Oh, I got it. I clicked off of it. Nope, I missed it that time. Retract. There it is. We'll kill our thing. Yeah, we got a little bit more. We'll We'll burn a little bit more out. There we go. Probably going to take this unmanned rover and drive north or south. My guess is south. Might drive a little south. So there we go. We'll do a little. Got our impact time here. Facing retrograde. Here's that. We'll burn a little bit. So we're closely approaching the surface. We're going to start our burn now and kill most of our velocity. Stay in retrograde just so we kill some vertical as well as horizontal. Let it fall a little bit more. Burn a little more. Fall a little more. In a nice flat spot. See how this goes. Want to be right around 10 meters when we drop this thing. And we don't want to be going much more than 10 meters per second either. If we can manage it. Put it on stability assist just so we don't. Oh, you see me, I mistouched my fingers. I'll have to try this again. Much more controlled burn this time. We're only about 5% throttle. That's all you need. 27.6. Being sensitive. See if we can rotate this thing, get a more favorable drop. Right around here. Here we go. Release it. Increase our throttle just a bit so we float away. Yeah, he rolled on his back. We'll see what happens here. Just gonna roll away a little bit because that's how Kerbal physics works. He may be fixable. Let's find out. First thing, we will deploy our antenna. And we can switch to the rover itself. We still have the brakes on. We will retract everything. That's what we're gonna do. This should help us roll. See that? If I can get it just right, we'll stabilize. Or not. There we go. Boom. There we go. Unmanned moon rover. There it is. Cut your brakes. Drive away. Now, before we get driving away with our rover, we want to check our operation time. We can see our survey/ComSat is in a good position. It's got a direct feed for us, and it will for quite a while. Our sun is okay. We're gonna have some sun for a couple hours or more. And we'll put our brakes on. See how the moon likes physics to keep being physics. Loves Mr. Newton's laws. So we'll park that for now, and we'll switch back to our engineer. Fly him back to our ship. And what we are going to have Danbert do is deposit us a nice little science station. So we'll actually rotate to the other side of the surface. Oh, wait. Sorry, Danbert. We'll collect a little science sample, why not? But in here, we've got some stuff to play with. Here's some panels. And unfortunately, we can only carry these one at a time. So what we'll do is open a lot of these bays and pin them. There's 4 bays with 3 items each. Some of our new science stuff. And we'll pin Danbert to Danbart. Sorry, Danbart. So we want to kind of stay in range, but we want to get our panels down first. So here's one panel. It's activating. Now we'll install our science equipment. We'll start with the 2 important pieces. Put those closer here. Here's our experiment control unit. Deploy that. Here's our antenna. Deploy this. Here is, and then left we have, oh, there's another power. Deploy this. There we go. Put him over here. Got him deployed. Head on back to our ship. Get our weather analyzer. Ain't no weather on the moon, but sure. Whatever, Kerbals. You guys figure it out. Here's our Grand Slam passive seismographer. Is that what it is? This one kind of expands a little bigger, so you want to make sure it's got space. You'll see when I deploy it. That should be good for that one. And then our one last part, which was the GOOB monitor. GOOB ED monitor. I think that's funny. And there's our deployed seismographer right there. Now we can check what everything's doing through our Probodyne experiment control station. We see we have 14 power units available. We only needed 4. We're all set. This will pump out some science. We'll be able to transmit the science. See, it's all about the science. So we've got our lander. We've deployed our rover. We're just going to collect some science here real quick and send our switch back over to the rover. So I'm just going to show real quick how easy it is to use the MechJeb's rover autopilot to sort of navigate this lunar landscape. We know we want to go south. I want to drive to the South Pole. I think I said that earlier. But we've got this giant crater south of us, right? Blocking our path. We don't necessarily want to go down and then back up. We want to stay up above, but still head south. well, we know our heading needs to be roughly 180 degrees, but what we can do is add waypoints and tell MechJeb that's where we want to drive. So we'll set our speed control down. We don't want to do any fast maneuvering here on the moon. And we will add a waypoint. We know we roughly want to go south, so we'll go around this way. It looks a little flatter. Add the waypoint, click drive. You can see our rover turns. Perform some basic science real quick. Collect it. And there we go. So now we're going to head towards this waypoint at 4 meters per second. You can see it'll take us roughly 7 minutes to get there. We know our energy expenditure is we're in a net positive. We're gaining energy. You see that? So let's add some more waypoints. I like to do this from the game scene zoomed out, just because it is a little more accurate. We're just going to kind of plot a course around this guy going south. So we know where that waypoint is. We can see the exact placement of it here. We don't want to drive on the side of this thing the whole time. We want to go a little faster than 4. So what we'll do is we'll add him here. It switched me. I did it in the wrong order. I need to click that off. Drive around the edge of this crater. Get out that way. There we go. That should have us returning south. We can see an adjusted view, so we can see it is now heading south. Zoom it back out. Add a couple more. We know that that's roughly south, so we know we can add this. It's easier to use smaller distances than big long ones. You don't necessarily want big long distances between waypoints. And what we will do now is we'll open this. We'll say this is the radius. So at 5 meters from that waypoint, the speed will reduce to 0, and we will go to the next waypoint. We don't want to necessarily cut to 0, and we don't necessarily want to have to drive all the way to this waypoint, right? So we're going to change this to 20 meters and the speed to 2. We want to slow down to 2, roughly 20 meters away, to execute the turn. We don't want to execute the turns fast, so we'll do all of these at 2. Even if they're more straight, that's okay. And you can see this sort of adds time, a little bit of time to our final ETA. But what this allows us to do is actually turn this speed up a little bit, so we can put it at 6. We can see that this time is dropping now. And that's it. This thing will have to drive with you playing. It won't move from a different craft, so use your time wisely. We know we have a certain period of daylight. We landed on the light side, so we know we have a little bit of daylight to actually get there. About an hour and a half from now, we'll be roughly south of the equator. And there's that. Done our science, ready to return home. We have our moon core targeted. We want that to be much closer, so we're going to warp through about 30 minutes or so. Let him get right over the top of us. We'll launch behind him. We're going to launch actually right in front of him, right around now. We'll catch up to him. So start off easing the ship up. Not going too nuts yet. We do want to get it straight up and down though right away. And then turn. There we go. We're going to pump this thing in the same orbit direction. Just get it up there. We're going to put it in an orbit right above our target. roughly the same inclination, pretty close, off by a degree or two. It'll happen by hand, it's okay. Push it up a little more. We want to be kissing his orbit just as he gets there. Turn our throttle all the way up. I think this is pretty good timing, and cut it. Look at that, look at that. Look how close we're pretty close. It'll be 6 kilometers and 363. It's gonna be close. We'll use our smart ASS to put target prograde. Now we're pointed at our friend. Do our relative velocity minus, so we'll kill our relative velocity to try to keep on the same distance. Just got orbit, so we're only 2.3 kilometers away. So close. Can use MechJeb to fine-tune approach. Say we want to come in with 20. Let's see what that's going to cost us. Some sort of error there. But it does put us fairly close to each other. We won't use that. We can do this by hand. Target plus. So we're going to just use our RCS to close this gap since we have plenty of monoprop fuel here. And we can also use the core, Moon core itself to eliminate some of our speed discrepancy, which I will do in a moment as well. So if I switch to this guy, Moon core lander target, and do the same thing. MechJeb, smart RCS. 0 our RVAL. Now we'll just slowly 0 out to him. Want to be careful here. We don't want to affect our orbit too much, which we have taken out of circularization for sure. There we go. 0 relative velocity. Switch back, and now we can have this guy. We notice our prograde is lining straight up. We want to take this up to about 2 meters per second. Maybe a little more since we're about 1 kilometer out. 2.5 or so. We see going to be very close. Definitely want to make sure also we do our control point from here, control from here. And And I'm also realizing we need to dock him on the top because of his shape. So what we can do is control him from here and tell him to face target prograde. Boom. Rotates our whole station that way. Our parts are lined up. Switch back. And one of the great parts of this setup is we now have a ship that's pretty adequately set up to shuttle people to Kerbals back and forth from the surface. So we can now start to design other missions. We have these nice cargo bays here that can be filled later on with more stuff brought with them, additional parts that can be installed. And like this doesn't have solar panels, so it needs some solar panels. It does have lots of charge, but it's a different story. There it is. Boom. Docking made easy. You just bring them in. 0.1 meters per second. That's how we do it. Aim the camera there. Cue the awesome music. Boom, we did it. Mission complete. Now, time to return home. That'll be for another time. Thanks for watching.